Hello everybody, and welcome back to the Praetorian. This is Roger Hansen and hybrid plants. Many hybrids are created by humans, but natural hybrids occur as well. Plant species hybridize more readily than animal species, and resulting hybrids are more often fertile hybrids and may reproduce. Though there still exists sterile hybrids and selective hybrid elimination, where the offspring are less able to survive and are thus eliminated before they can reproduce, a number of plants are the result of hybridization and polyploidy, with many plant species easily cross-pollinating and producing variable seeds. The distinction between each species is often maintained by geographical isolation or differences in the flowering period, since plants hybridize frequently without much work. They are often created by humans in order to produce improved plants. These improvements can include the production of more or improved seeds, fruits, or other plant parts for consumption, or to make a plant more winter or heat hardy, or improve its growth and or appearance for use of horticulture. Much work is now being done with hybrids to produce more disease-resistant plants for both agriculture and horticulture crops. In many groups of plants, hybridization has been used to produce larger and more showy flowers and new flower colors. Many plant genera and species have their origins in polyploidy. Autopolyploidy results from the sudden multiplication in the number of chromosomes in typical normal populations, caused by unsuccessful separation of the chromosomes during meiosis. Tetraploids, plants with 4 sets of chromosomes rather than 2, are common in a number of different groups of plants, and over time these plants can differentiate into distinct species from the normal diploid line. 1. Onethra lumarchiana, and the diploid species has 14 chromosomes. This species has spontaneously given rise to plants with 28 chromosomes that have been given the name Oenthra gigas. When hybrids are formed between the tetraploids and the diploid population, the resulting offspring tends to be sterile triploids, thus effectively stopping the intermixing of genes between the two groups of plants, unless the diploids in rare cases produce unreduced gametes. And excuse me for mispronouncing the words, they're pretty strange. Gametes, producing unreduced gametes. Another form of polyploidy, called allopolyploidy, occurs when two different species mate and produce polyploid hybrids. Usually the typical chromosome number is doubled, and the 4 sets of chromosomes can pair up during meiosis. Thus, the polyploids can produce offspring. Usually, these offspring can mate and produce with each other, but cannot backcross with the parent species. Allopolypoids may be able to adopt a new habitat that neither of their parent species inhabited. Sterility in a non-polyploid hybrid is often a result of chromosome number. If parents are of different chromosome pair numbers, the offspring will have an odd number of chromosomes, leaving them unable to produce chromosomally balanced gametes or gametes. While this is undesirable in a crop such as wheat, where growing a crop would produce no seeds would be pointless, it is an attractive attribute in some fruits. Triploid bananas and watermelons are intentionally bred because they produce no seeds and are parthenocarpic. Then you have the heterosis. Hybrids are sometimes stronger than either parent variety, a phenomenon most common with plant hybrids, which when present is known as hybrid vigor, heterosis, or heterozygote advantage. A transgressive phenotype is a phenotype displaying more extreme characteristics than either of the parent lines. Plant breeders make use of a number of techniques to produce hybrids, including line breeding and the formation of complex hybrids. An economically important example is hybrid maize, which is corn, which provides a considerable seed yield advantage over open pollinated varieties. Hybrid seed dominates the commercial maize seed market in the United States, Canada, and many other major maize producing countries. And the examples of plant hybrids, the multiplication symbol, not italicized, indicates a hybrid in the Latin binomial non-cultural placed before the binomial. It indicates a hybrid between species from different genera. Okay, yeah, I'm not even going to go there. All that's just a little bit too ridiculous. And they've got crazy names for plants. Now, I can also read over hybrids in nature. But let me see how much time I got here. Yeah, we're going on 33 minutes now, so I'm going to stop here and go over my audio and continue later on. This would make this is going on 35, so this will make 2 or 4 videos altogether that I have for hybridization, and I'm okay with that. I'll make another one to finish it up and get back to you on it. I might have to actually have 6 videos. And like I said, sorry about the clicking on the videos. Also sorry about my bad reading and pronunciation. These words are pretty complex, but I am working on it. Thank you for watching. If you like this video, please like, subscribe, share, make comments, and I'd love to hear what you have to say. You know, and I'd be willing to respond to any comments that you make. So thanks for watching. Bye.